So for this video, we're going to be going over graphing linear equations. You might be asking yourself, what is a linear equation? To help us with that, we're going to use our Freyer definition models. Okay. And we have two to do. All the resources can be found on the web page. So let's first do the definition of a linear equation. So a linear equation is an equation whose graph is a line. It's a pretty straightforward definition. And this whole unit is on graphing linear equations. So there'll be more features about these kind of equations coming up, but this is just a basic definition. Characteristics. They can come in different forms. One popular one is y equals mx plus b, where m is some number and b is some number. And you'll see that more in the examples. Okay. Another characteristic is that it forms a straight line. So it's not going to be curved, it's not going to go up and then down, it's just going to be straight, constant line. Some examples of linear equations: y equals 3x plus 1. As soon as we have two variables, we've got a y and an x. That is the most common that you'll see here for 8th grade math. Another example: y equals negative 1/2 x minus 4. Another example is if you just had a line like y equals 4. Or maybe x equals negative 3. And when we start to graph these lines, you'll notice that all of them are going to be a straight line. Non-examples are when you have equations that have exponents, like y equals x squared. When you have radicals, like y equals the square root of x. When you have x in your denominator. Those are some non-examples. And now what you're going to do is you're going to take this Freyer definition and fold it in half, and you're going to write linear equations. Right there. And you're going to glue the bottom side to the book so that when it's in there, all you have to do is open it up and you have your definition, shut it down, and then we have some more space to work with. So our next Freyer definition is solutions of linear equations. Now, a solution to a linear equation are the xy points on the line of the linear equation. And a characteristic is that it's always an ordered pair, x and y. So they're two numbers that are related. They're combined, they're joined together. And so for an example of a solution would be if the line goes through the point 3, 4, then that would be a solution. Or if it went through 1/2, 6. It doesn't matter if it's a fraction, it's still a number. It could go through the point 0, 0, which is actually pretty common. Could go through some negative numbers. -2, -6. Okay. So it's any of those points that are on the line. These are the xy coordinates that are on the coordinate plane. Non-examples, well, non-examples would be for 8th grade math if you had like 3 coordinates. because that's x, y, and z. And we only have two variable equations. Another non-example is if you were to give your solution as like x equals 3 and y equals 4 instead of putting it as a coordinate pair. So we don't want to do that. Okay. Now just like with the last one, you're going to fold this down just like so. Sorry, the camera's blinking. And then you're going to write solutions of linear equations. And then you'll glue the bottom and you'll put it about here. For our first example, which you're going to write underneath the two definitions, we're going to graph the equation y equals negative 2x plus 1. We're going to graph it on this coordinate plane here. These handouts you can find on the links of the resources on the webpage, and also in the milk crate in the back of the room. So we're going to want two different colors for this one. I'm going to do my x values in blue and my y values in red. Now most of what we're going to be doing in this unit is taking an equation like y equals negative 2x plus 1 and showing the graph of all of the solutions of the equation. Okay? So one way to find solutions and actually make a line is to choose x values and find what the y values are going to be. Now when you're doing this, I want you to always do three numbers for x values, at least three. Okay, a negative, 0, and a positive. So for this one we're going to do negative 1, 0, and positive 2. Now, to figure out what the y value is, we're going to use the equation. It says y equals negative 2x plus 1. Well, if x is negative 1, then what is y? And we're going to write that out for every single point. Now you notice for every single one of these points, I'm always going to be using this equation. Negative 2 times the x value plus 1. So what I've done for my table is I just kind of wrote a shell of the equation. And I know that when I put in negative 1 for x, negative 2 times negative 1 is positive 2, plus another 1 gives me positive 3. So the y value for negative 1 is 3. And then I do it for 0. Negative 2 times 0 is 0, plus 1 is 1. Now for 2. Negative 2 times positive 2 is negative 4, plus 1 is negative 3. And now I have my xy pairs. Remember I said when we did the definitions that these pairs are related. And they're related because of these equations. That's how we show the relationship. So our first step is to make the xy table, and our second step is going to be to graph these points on this line. Okay. Now, the horizontal numbers, those are the x values. Okay, so I'm going to shade that line in blue. The vertical, those are the y values. And these are positive y's, negative x, positive x. Okay. And now we're going to plot these points on this coordinate plane. Our first point is -1, 3. So it's -1 on x and positive 3 on y. There's our first solution to the equation. Our next point is on 0, 1. So that's 0 on x and then 1 on y. Right there. And our last point is 2, -3. Positive 2 on x and then -3 on y. And we have our 3 spots, or our 3 coordinates. Now, what you want to do here is we want to actually make a line through these points. So we're going to use a straight edge. I don't really have a straight edge here, but I have something that's straight. It's just not a ruler. So this line shows all of... Now that we have a line with all the solutions, let's test a point on this line that we didn't use here and see if it makes this equation true. Because if it makes the equation true, then it is a solution. And let's choose the point 1, -1. So again, using color, that's going to be 1 on x and -1 on y. So in my equation, I would have y equals -2 times x plus 1, where x is 1. So y equals -2 times 1 plus 1. -2 times 1 is -2, plus 1 gives me -1. So this point, 1, -1, is a solution of this equation. And I could have picked any of these points, and they all would have been solutions to the equation. So if it's on the line, then you can put it in here, and you're going to get a true statement. On the left side of your notebook, you're going to graph the following equations. Y equals -2x minus 4, and y equals 3x. So you can take the small graphs and graph your solutions on here, and then tape them in, and then go show your teacher.